Welcome to the New Jersey Astronomical Association. Tonight's presentation, How to Find Apollo Landing Sites, is presented by James Chen. James Chen is retired from the Department of Navy and Federal Aviation Administration, where he worked as a radar and surveillance systems engineer. A guest lecturer at local Washington, D.C., Northern Virginia, Maryland astronomy clubs on amateur astronomy topics of eyepiece design and optical filters. He wrote a short Astronomy Magazine article on Dobsonian telescope design, November 1989, and served as a sales consultant to two Washington, D.C. area telescope stores for over 30 years. James is a frequent speaker at astronomy clubs near his home in Virginia and has also spoken at Princeton on the topic of astronomy for older eyes. Jim has authored 5 books for Springer publication, the Patrick Moore Practical Astronomy series, and his book, How to Find the Apollo Landing Sites, would be a great companion to tonight's talk. With that, I will send it over to you, Jim.
Scopes and accessories, but I'm sure for this august group, I won't have to go into too much detail on that. Everybody's probably overloaded with telescope equipment, and so we'll have to delve too deeply in that area. And then we'll go through the different missions. Mostly I'll show you where they landed and talk a little bit about each mission. And then we'll end up talking a little bit about the unmanned probes that we sent to the moon prior to Apollo, and then talk a little bit about the future. Next slide. So the genesis of the book was really twofold. I have a son who at the time was working for NASA, and he came home and exclaimed to me, you know, Dad, you can use NASA pictures free of charge. It's public domain. You know, you always wanted to write a book. And I said, yes. Well, he says, is this your big chance? And then I would go out to astronomy outreaches, and I would be always having people, young and old, asking me, you know, where did the astronauts land on the moon, and can we see the flag on the moon? Are the most popular questions, and so I put those two things together, and that was the genesis for the book and this talk. So here we show the basics of the moon, a little over 2,100 miles in diameter, 1/6 the gravity of Earth, from 225,000 to almost 252,000 miles, perigee and apogee. We do see phases of the moon because the moon does go around, orbit the Earth. The moon does have a very, very minute atmosphere, as you can see, certainly not the density that we experience on Earth. So that's just a little bit on moon basics. Next slide. So recommendations for telescopes, like I won't spend too much time here. The big thing is all my years of working in 2 different telescope stores is that there's kind of a tug of war between 2 rules of thumb. The first rule of thumb especially applies to young people, who are aperture rules. You know, the bigger the telescope, the more you can see, and you get caught in this aperture race between friends of getting bigger and bigger telescopes. But then when you get to my age, where I'm 68 years old, and you know, that telescope that really seemed light when I was 30 and 40 years old really seems very, very heavy now for me to move, and start looking more favorably at smaller telescopes. And so you have this tug of war between the telescope that gets used the most versus the biggest telescope, and you find a sweet spot where you're happy. For viewing the moon, we've got three different basic families of telescopes, and there are pluses and minuses for all of them. We won't get into a lot of detail there, but what you're really striving for is good sharpness, good contrast, and ease of use. Eyepiece is the same way, good contrast, good sharpness. Viewing the moon, you don't need a wide field of views like is preferred when you're looking at deep sky objects. Your 82-degree field of view naglers and your 100-degree or 105-degree field of view eyepieces really, they can be used to looking at the moon, but your standard Plossls and the Abbey orthoscopics work just fine observing the moon. It doesn't really, unfortunately, the moon is very, very bright. It doesn't put a lot of pressure on you to get a huge aperture or really expensive eyepieces. You can view the moon through a very modest equipment. So we'll go to the next slide. Okay. And we'll start talking about the actual missions. And as we all know, last year around this time, we celebrated the 50th anniversary of the man's first landing on the moon, with Armstrong and Buzz Aldrin landing on the moon and Mike Collins manning the command module. For those of my era and my age, we remember sitting in front of the telescope, in front of the television and watching all these events unfold. And very exciting time. Billions of people watched the landing on the moon. And so it's historic. It's one of those events that in life where you remember where you were when it occurs. Next slide. So here's a picture of the moon, and it's located. The landing site for Apollo 11 is in the lower portion of the Sea of Tranquility, or Maria Tranquilitas. I can't say it right, but as you can see, it's one of the easiest sites to spot through a telescope. When I'm doing outreaches, that's probably the favorite landing spot site to point out to people. It looks very smooth, but as we know from the landing, it wasn't smooth. There was lots of boulders, and Armstrong had to take control of the LEM in order to perform the landing, and they had to land further down site than their original spot. For those of you last year or so, there was a movie called First Man that was about Neil Armstrong, and if you're familiar with that movie, or if you've seen that movie, and if you've seen the various documentaries about Apollo 11, you know that during the landing, they got a series of error messages in the LEM, computer error messages 1201 and 1202, which basically said the computer was telling the astronauts, "I've got too much to do. What are you doing to me? I don't have enough memory." And as it turned out, the root of the cause was it didn't have enough memory. We're all used in this modern era of having a tremendous amount of memory at our hands. My own iPhone has 64 gigabytes of memory in it. Geez, I remember my first computer was a TI-99 computer, and it had 48K of memory. And at the time I said, ooh, that's a lot of memory. Well, believe it or not, the Apollo LEM computer had 2K of memory. Only 2,048. Yeah, that's it. That's all it had. And what was occurring during the landing sequence was they had the landing radar feeding data to the computer, but they had to leave their rendezvous radar on just in case they had to abort and unite with Columbia again. And that was feeding data. And the two radar data streams were colliding at the computer, and the computer would just go, I can't handle this. And so they, several times during the landing sequence, they had to clear the landing, clear the memory. Oh, by the way, the first error message, the 1202 error message that came across, happened at exactly at the time that you didn't want to happen during the landing sequence. There was, in Apollo, all the landings, there was a 12-second period during the landing sequence in which if they aborted during that 10-second period, they did not have enough fuel to get back, to overcome gravity and get back to the command module. And they called that the dead man zone. And unfortunately, the first error message, the 1202 message, came right during the dead man zone. And the ground controllers were in a little bit of a panic because they knew they couldn't do anything until they were out of the dead man zone. So the landing was complicated. And then we had Armstrong taking control to avoid boulders. He eventually touched down with, some say 17 seconds left of fuel, some say 20, some say 46. The numbers vary, but they didn't have a lot of fuel left. And so it was, the suspense was, the landing was a little more exciting to the NASA control room people than they expected. Next slide, please. So the Apollo 11 site today, in 2009, the Lunar Reconnaissance Orbiter took a picture of the landing site from 50 miles above the moon. And you can see to the left of the crater there, the descent module of the Eagle. And so everything's still there. It hasn't moved. There's no weather there to cause anything to change. And as you can see, even from that distance, you cannot see the flag. Sorry, kids. So we'll go to the next slide. So Aldrin and Armstrong spent 2.5 hours walking on the moon and a total of 22 hours on the moon. They had certain objectives to accomplish. The first thing was to set up the American flag. Aldrin had a number of experiments that upon getting down from the ladder, that he was supposed to just kind of play around with the lunar surface soil and get a sense of what it was like, you know, if you kicked up any dust clouds or what the shadow of effects of the sun and the shadow were. Meanwhile, Armstrong, the very first thing he did after saying his famous one small step for man, one giant leap for mankind, the very next thing he did was bend down, grab a handful of soil, lunar soil, and put it in a special pocket in the leg of his spacesuit. So just in case they had to do an emergency abort and lift off, they would bring back something. There is a story about the two men as they climbed out of the LEM that is not included in my book. I wanted to include it in my book. It was in my book. However, my wife talked me out of having it in my book, but I always include it in my talks. As we all know, Neil Armstrong was the first man to step on the moon. Buzz Aldrin has a unique fame to this, and he admitted this in an interview years later after the mission. If you ever watch a replay of the astronauts walking on the moon, you'll notice that as Buzz Aldrin comes down the ladder to step off the LEM, he kind of hesitates, and then he steps off. And it was later revealed that Buzz Aldrin said that he took that time before he made the last step in order to, shall we say, relieve himself. So as it goes, Neil Armstrong was the first man to walk on the moon, but Buzz Aldrin was the first man to pee on the moon. So the astronauts then had a very simplified scientific package that they were required to set up. And then they slept in the LEM after their spacewalk, the moonwalk. And then after 22 hours, they returned to Columbia. Next slide. So the early Apollo surface experiment package included basically 3 experiments that required a minimal amount of time to set up. The first one is the laser ranging retroreflector. The second one was a passive seismic experiment package, which unfortunately failed after 21 days. And the third one was a solar wind composition experiment. And we'll go a little more detail in the next slides. So the next slide is a picture of the LEM Eagle and with the seismic experiment package. Like I said, this package worked for about 21 days, and then it just stopped working. Next slide. But the package was sensitive enough to detect Armstrong kind of moving around in his sleep in the LEM when they had their sleep period. Next slide. So this is the famous lunar laser ranging retroreflector, the LRRR, which as you see it in the picture, each one of those little holes there actually contains a prism that was specially designed so that a laser light that would enter straight in would be reflected straight back. For those of you who are fans of the TV show The Big Bang Theory, there was an episode in which the boys were on the roof of their apartment building with a laser, with a telescope, and with computer equipment, and they were able to measure the distance from their rooftops to the moon and back. This is the only Apollo experiment that is still active because it's totally passive. So next slide. And so from the LRRR, we've determined the distance to the moon for perigee and apogee. And one of the most interesting results was that they found that the moon is moving away from the Earth at a very slow rate of 4 centimeters per year. So if you stick around long enough, the moon will eventually fly away from the Earth. Next slide. The solar wind composition experiment is a very simplistic experiment. They had a little framework, as you see there, basically a little sail of aluminum foil. And they set it up and let the solar wind pound on it. And before they left the moon, they rolled it up and took it back to NASA in the Apollo, and they were able to let's go to the next slide. And as a result of the analysis of the foil, they found isotopes of helium, neon, and argon. And of particular interest is helium-3. For those interested in nuclear science and nuclear fission, you'll recognize that helium-3 is one of the key isotopes that they're using in order to develop a fusion reactor. So if that turns out to be a feasible technology, going back to the moon and in a sense farming helium-3 seems like an ideal situation. Next slide. The astronauts came back with the soil samples and rock samples, and there were 3 previously unknown minerals that were found in the samples. The first one, there's amalgam of the astronaut names, and it was basically a basalt high in titanium. It was later samples were found in Montana. A second mineral was later found in Australia, and the third one listed there in Japan, Sweden, Finland, and good old South Carolina. So next slide. One of the funniest things that happened on this mission was the fact that upon their return, they were put into quarantine, and 3 astronauts, as the aircraft carrier was coming into Honolulu, they were handed a U.S. Customs form. They were required to declare the moon rocks and the moon dust that they had collected. And so this is a photo of the actual form that they filled out. You'll notice that there's no value attached to it, to the samples, just that they collected moon rocks and moon dust. I always found that very humorous. They were the only crew that had to fill out a customs form. After this particular mission, the powers that be said, "This is stupid," and so they never did it again. So next slide. So in November of 1969, Apollo 12 took off. This was in many of NASA's higher ups thought that this would be the successful mission for landing on the moon first. They actually did not expect Apollo 11 to be successful, but Apollo 11 was successful. So these guys turned out to be the second team to go to the moon, with Pete Conrad as commander, Alan Bean, who I'll talk a little bit about more later, and the command module was pilot was Dick Gordon. This one was an interesting mission that they were going to attempt a pinpoint landing. And they wanted to get close to where Surveyor 3 had landed in the Ocean of Storms. It was the first of what they called the H missions. NASA had assigned letter designations to the different missions, with the A missions being Apollo orbital flights unmanned, moving up the chain until you got to G mission, which was Apollo 11. H mission were Apollo 12, 13, and 14. 15, 16, and 17 were J missions. And what distinguished the J missions from the H missions was the H missions were very basic missions that all they needed to set up scientific experiments, gather rocks, but they did this all just by walking around on the surface. Whereas the J missions had the lunar rover. Next slide. So here, it's a little more challenging finding where Apollo 12 landed. You have to spot Copernicus there, and south of that is the Ocean of Storms, and that's where the Apollo 12 landed. You'll find out later that the Apollo 14 landed in Fra Mauro, which was not that far away from Apollo 12. So I've often wondered, it seemed like they could have done a better job looking for a different landing zone, but be that as it may. This landing site's a little more challenging to find. We'll go to the next slide. And here from the LRO, you can see the descent stage. You can also see where they set up the experiments. And you can also see where the Surveyor 3 is, which is off to the right on the other side of the crater from the descent module. Next slide. So the primary objectives of 12 was to do the surface sampling. They set up a full surface experiment package this time. They obviously did a fine job in pinpoint landing. They had an extended work period on the moon and gained some experience from that. Meanwhile, the command module pilot was required to take photographs of candidate sites for future missions. The secondary objective was to go down to Surveyor 3 and retrieve some parts of it for inspection, because it had been there since 1967. They wanted to see what kind of degradation had occurred to the equipment with that prolonged exposure to the moon's environment. They also wanted to try to answer the question of Surveyor 3, because Surveyor 3 not only was a soft landing, one of the early soft landings by a man-made object. It was also the first manned or unmanned spacecraft to launch itself off the surface. And was apparently, after the evaluation of the equipment, they discovered that basically Surveyor 3 landed on the moon, didn't shut off its engines, and basically hopped again across the surface and landed again in its final resting spot. Next slide. So the major discoveries of Apollo 12, they did discover a very unique material on the moon that's not found on Earth. It was nicknamed creep. No, this is not what my wife said to me on our first date. This was actually describing the potassium and the rare earth elements and phosphorus that's on the moon. So that's how you get creep. And it was found in samples of the different glasses and brachias that Apollo 12 returned. This was an early indication of what has now become the primary theory of how the moon was formed. Up until then, many thought that the moon was formed at the same time as the Earth. from the same cloud of dust and gases. But because of this material, the pervading theory right now is that the early Earth suffered a collision from a Mars-sized body, and the splash that resulted from that eventually coalesced into becoming the moon. And so that was a very, very significant result of the moon missions. Next slide. In my study of all the missions, there was always this concern about mass cons. Mass cons are mass concentrations on the moon, which caused variations in the gravity. Gravity wasn't constant across the face of the moon, and it caused all sorts of problems for both NASA and Russian lunar missions. The data from all the Apollo missions did not find the answer. We now know today that there are only 4 frozen orbits around the moon, 27 degrees, 50 degrees, 70 degrees, and 86 degrees orbital inclination. And it wasn't until the 2012 GRAIL mission, the NASA mission, that confirmed that the lunar mass cons were caused by large asteroids impacting the young moon when the moon only had a very thin crust and did not cause the breakup of the asteroids. And basically these asteroids would break through the thin crust and kind of lodge itself in the molten mantle. Next slide. So here we have a picture of Apollo 12. This was Al Bean taking a picture of Pete Conrad posing next to the Surveyor 3, and in the background you can see the LEM. Next slide. Here's a picture of a part of the LSEP, scientific package. Oops. Where am I? Oh, there. Okay, next slide. Now,
Jim,
Alan Bean.
Jim, I'd just like to remind
Yes.
our viewers that if they have any questions, we are monitoring the chat line. So just ask your questions on the YouTube chat channel, our YouTube channel, and we'll be able to give them to Jim. Thank you. Please continue.
Okay. As you know, Alan Bean was the LEM pilot, and after he retired from NASA, he became a painter, and he painted a number of Apollo-based type of paintings, of which this is one of them.
Please stand by. We're having a technical difficulty.
Yes?
Okay.
Yes. Yeah, we'll go to the next slide.
Okay.
So as you know, Apollo 13 really didn't make it to the moon. They made it around the moon, but not to the moon. We're all familiar with the movie. that came out that misquoted Jim Lovell. It was Houston, we had a problem, not Houston, we have a problem. It was a successful failure, but they did manage to land something on the moon, which you'll see shortly. Next slide. So here's a picture of the damaged service module. As we all know, an oxygen tank exploded from, and that particular oxygen tank had been originally supposed to be on Apollo 10, and it was accidentally dropped, so they had to replace it, and they refurbished the oxygen tank. It was supposed to go on Apollo 11, and it failed its tests, so they put it back into the repair shop. By this time, you think somebody would have thought, maybe we should give up on this one. This one's a bad component. So they thought they repaired it. They put it back in, and it shorted out when they did the oxygen stir, blew up, and thus ended Apollo 13's mission to Fra Mauro. Next slide. But as we see, we actually did accomplish something, because the third stage of Apollo 13 did follow the path to the moon and did impact the moon. And this is a picture from the LRO. And next slide. And the Apollo 12 seismic gear picked up the ringing of that impact of the moon. So we did get something out of Apollo 13. Next slide. So at the end of Apollo 13, the engineers at Grumman thought, gee, you know, this was really cool. We were the tow truck for Apollo 13. We ought to write up a towing bill. And so they did. One of the engineers for the LEM made up this bill, and it's $4 for the first mile, $1 each for every additional mile. It was $8 a day for the additional passenger on board the LEM. They gave a little company discount there, and it came out to $417,000 and change. And for the fun of it, they sent it up the corporate ladder to see if anybody would sign it. It got to the level of a senior vice president who found this just abhorrent, and was ready to fire the engineer when the CEO of Grumman saw the bill, and he said, "Hey, this is funny. I'll sign it." So he signed it, and they sent it to North American, who was the builder of the command module, and their response was, well, because of government billing, we still haven't been paid for the first two LEMs that we delivered to the moon. So we'll have to hold off on paying this tow bill. So that was the funny story that came out of Apollo 13. Come on. Now my computer's freezing up a little bit. Oh, here we go. All right, so we finally get to Apollo 14. And this is the mission in which Alan Shepard made his grand return to space. Following his suborbital flight of Freedom 7, he experienced an inner ear problem, a condition that caused him to have balance issues. He had all sorts of, and he was grounded for a number of years. And it wasn't until there was an experimental surgery that became available that they were able to correct his problem. And he was cleared to fly, and he became the commander of Apollo 14. And they took over the original mission of Apollo 13 which is to land in Fra-Mauro. This is the mission which is probably best remembered by Alan Shepard's golf shots on the moon. And this was the last of the H missions. Next slide.
Jim, before we before we get to the next slide, there was a question about Apollo 13. If Apollo 13 had landed, there would have been an additional site for Apollo 17. Do you know where that would have been?
I'd have to look it up. I did remember Apollo 18 was supposed to go there, but I don't recall offhand. Yes, should be on the actual landing site, the moon picture. And as you see, it's actually fairly close to the Ocean of Storms where Apollo 12 landed. So if you see the Apollo 12 landing site, you'll have the same field of view of your eyepiece of the Apollo 14 landing site. So you get a 2-for-1 deal there with your telescope. Let's go to the next slide. And here we have another LRRO photo 50 miles above the landing site. And you can see all where the astronauts walked and setting up the experiments, and those footprints are still there, and they'll probably be there for years and years and for eons. There's no wind, there's no rain, there's no snow, there's nothing there to disturb it. So it's, in a sense, it's a type of immortality. Next slide. And the next slide is really interesting. If you look to the upper right-hand corner, you should be able to spot what looks like a white rod lying on the side, and then in front of that, a little white ball. And the ball is Alan Shepard's first golf shot. Alan Shepard had a golf club head of a 6-iron, modified so it would attach to a digging implement, and they used that as a golf club. And his first ball he topped, and that's how far it went. Then Edgar Mitchell grabbed another digging implement and used it as a javelin, and that's why that rod is way out there. And then the second shot that Alan Shepard made, he claimed it went for miles and miles and miles. But scientists have analyzed the moon's gravity and what kind of forces that Alan Shepard might have been able to hit the ball with. And with a 6-iron loft, they figured he hit one about 600 yards, which for a 6-iron shot is pretty impressive. So, so Apollo 14, that's the Apollo 14 story. We'll go to Apollo 15 next slide. And Apollo 15 was 49 years ago tomorrow, and featured Dave Scott as the commander, Al Warden, who unfortunately passed away earlier this year, as the command module pilot, and James Irwin as the LEM pilot. So this was the longest lunar stay up until that time, 66 hours, 54 minutes. They landed in the Hadley Rill Apennine Mountains region. It was the first J mission, which featured the lunar rover, which if you study the NASA engineering, the design of the lunar rover was really quite an exercise. We're not going to talk about it in any detail here, but I would suggest you look into that on your own. Next slide. So the Hadley Rill Apennine Mountain region is you look at the moon, you find the Sea of Serenity, and it's on the left hand side of the Sea of Serenity. It's right on the edge. That's where the Hadley Rill and the Apennine Mountains are. A fairly easy site to identify. Next slide. And here again, from 50 miles up, you can see where the LSEP is, the Scientific Experiments Package. Well, the LRRR was set up where the Falcon landed. And you can see the final parking spot of the first lunar rover. The next slide. On every mission, they took up a lunar laser ranging retroreflector. Next slide. But the real main feature was the lunar rover, which extended their range of exploration, although they limited this particular crew to keep the LEM in sight because they didn't want the lunar rover to break down and have the astronauts having to walk a great distance and having to retrace their steps a long way. So and although it extended their range, they also limited the range. An interesting story about the lunar rover is, for those of you who are customers or follow eBay, about 20 or 25 years ago, there was an auction on eBay for the lunar rovers, the quantity of 3, and they were described as 4-wheel drive roadsters, open top, low mileage, and because there's no UPS or FedEx delivery, you had to go for local pickup. This auction lasted for 1 day. Oh, by the way, that day was April 1st. And how I found out about this particular auction was a friend of mine did the listing. And so we got a lot of good chuckles out of that. Next slide.
Jim, we have another question.
Okay.
We have a couple of them actually. So one is there any interest in the next lunar mission to revisit one of these Apollo landing sites? And a second question, why don't you answer that one first and we'll go to the second question.
Not that I know of. I would suppose that if we're dealing with a NASA mission or a European Space Agency mission, they would do it, but not on an early mission. I think if Elon Musk makes it to the moon with his Starship, I would think that he would want to take his tourists to one of these landing sites as a tour site. But I don't think the other country-based space programs are entertaining going back to any of these, because there's plenty of other sites on the moon that demand a lot of interest. Okay, second question.
And the second question, is it impossible for the Hubble cameras to focus on these Apollo landing sites?
Yes. The Hubble is not designed to, it's designed to look at objects very, very far, far, far away. You could put it, focus it on the moon, but you really don't get any real gain out of it. You'd be restricted to almost the same thing as we experience now with, if we were to turn the 200-inch Hale telescope at Mount Palomar at the moon. The smallest thing you would still see is something the size of the Rose Bowl. I always, like I said, I always describe what you can see through a telescope, earthbound telescope, is the smallest thing you can see is about the size of the Rose Bowl. And what we left behind was a descent module, which is 2 U-Haul trucks parked side by side. So you're not going to be able to see the sights. Okay, so we're at the Genesis rock. At the time when they discovered that, they really thought they had found the primordial crust sample of the earliest crust of the moon when it formed. Upon return to the Earth and further examination, they have discovered that we were a little carried away there. It's not really the Genesis rock. It's still a form of breccia and caused by some sort of impact, but it's a really old rock. And so it's still considered the oldest sample that we've brought back from the moon, but it's still not the Genesis rock, still not that primordial crust sample. Now, Apollo 15 up on its landing had a little more excitement than usual. Apollo 15, as it returned, had some leftover fuel in one of its thrusters, and as the chutes popped out, that fuel kind of escaped and burned off one of the parachutes. So instead of landing softly into the ocean at a gentle 19 miles an hour with 3 chutes, it kind of hit a little bit faster around the high 20s and speed. And not only that, the command module landed in what they called stable 2 position, which meant they were facing downward into the ocean instead of landing and facing upward towards the air. So it was a little uncomfortable for them until the Navy divers got there, attached the flotation equipment, and flipped the capsule over. As we find, all these missions had their moments of equipment failures. Some disastrous, like Apollo 13, and some kind of minor glitches. And this would be a minor glitch. So the next mission was Apollo 16. As many in NASA described this as the almost perfect mission, commanded by John Young. And Tom Mattingly finally got his chance to go into space after being kicked off Apollo 13 for measles that never happened. And then Charlie Duke was the LEM pilot. And they landed in the highlands of the Descartes region. Next slide. So the Descartes region is fairly easy to find if you have your telescope out, and if you have Apollo 11's landing site in sight, you probably see Apollo 16 landing site also. It's fairly near the Apollo 11 site, although 7,200 feet higher in elevation. Next slide. And what we have here is, oops. Oh, okay, there we go. Here again we have the final parking spot of the lunar rover, where the LEM descent module is, stage is. You'll see the ALSEP set up, and they ran a geophone line for extended seismic measurements. Next slide.
We have another question, and it is,
okay,
what is the farthest that any of the astronauts traveled from the LEM, from the lunar module?
Oh, that I believe occurred on Apollo 17. They drove quite a distance because they had a very extended stay on the moon. I'd have to look it up in my book. I know I've got it in my book, but it's not on the top of my head at the moment. Which sounds like a plug for my book, and I apologize, but so the mission objectives of 16 was to explore, pick up materials and stuff, set up the same type of equipment for the LSEP, and conduct some additional photographing. And the main purpose was to gather material and measurements from a site that was significantly higher than the Apollo 11 mission. So the next slide is on Apollo 15 and 16. They had kind of little small subsatellites, they called them, to measure particles and fields around the moon. And then Apollo 15's launching of the little mini satellite, it had an orbital inclination of 28 degrees, which was really close to the frozen orbit of 27 degrees. And so it was fairly stable in its orbit around the moon, and it gathered its data. On Apollo 16, they launched their mini satellite, but they mistakenly put it in an orbital inclination of 11 degrees. And this caused that mini satellite to absolutely go nuts in its orbit. At one point, it came as close to the surface as 5 miles and went out as far as 400 miles. And then it settled into a circular orbit, and NASA thought, okay, we're in good shape. And then the orbit went nuts again, and eventually, after 35 days, it crashed into the moon. And it was all because of the mass cons, because of the mass concentrations and the fluctuation of the gravity. And this is a perfect example of the effects of the mass cons. Next slide. So here we have a picture of the LEM and one of the rovers that was up for sale. As I said, the auction is over. Next slide is a picture of Charlie Duke taking core sample near Boulder. When the Apollo 16 crew returned, like I said, this particular mission was very, very successful. But they did have a little incident with the command module after its return. They took it into a hangar to be refurbished so it could go on display in museums. And there was, here again, some leftover fuel in the thruster tanks exploded and blew out all the windows of the refurbishment building. Fortunately, nobody was hurt, but it was a little bit of excitement after the fact. So we go to the final mission, Apollo 17. Now, for those of you who own my book, and for those of you who will eventually buy my book, I have to make an apology. In my book, I neglected to include the actual dates of the mission, which was 7 through 19 of December of 1972. Now, I don't claim this mistake as being solely mine. My wife proofread the book, and she missed it. My editor proofread the book, she missed it. The Springer production editors read the book, they missed it. The Springer production editors read my book, and they missed it. So we had 5 chances to catch this error, and we managed to miss it. So here are the dates. This was the only mission which we actually had a true scientist on board, Dr. Harrison Schmidt. He was a geologist who had been working with the astronauts on learning how to identify rocks and soil samples And he was originally scheduled to go on Apollo 18, but when 18, 19, and 20 were canceled, they moved him up to Apollo 17. So this last mission was to the Taurus-Littrow region. It was the longest lunar stay. They were up there for 74 hours and almost 75 hours. They came back with 243 pounds of lunar samples. And also this was the only mission in which they had to perform a body job on their lunar rover. The story goes that Cernan, his hammer got caught in one of the fenders of the lunar rover, and he accidentally ripped the fender off. So when they attempted to drive the lunar rover, it was tossing dust all over Schmidt and Cernan. And so they had to take a mission manual, and with that and duct tape, were able to fashion a temporary fender for the lunar rover, and it worked for the rest of the mission. So that's a little interesting sidelight to the mission. The lunar science objectives of this mission, you can definitely see from this. I'm not going to read all this to you. You can all read yourself, but definitely very, very geologic in nature. A lot of soil samples, a lot of trenches dug, all sorts of stuff, and a lot of this because they'd had a bona fide geologist on board the mission. Next slide. And so Taurus-Littrow is right as we towards the top of where the Sea of Tranquility meets with the Sea of Serenity, right in that region. It's easy to spot through your telescope. This is the final landing site. Next slide. And from another view from the LRO of that landing site. So if you ever have any doubters of that we never landed on the moon, yes, we have pictures of the landing sites. Well, of course, then again, these doubters are probably going to come up with some stupid argument, and it's a never-ending cycle. Next slide. So during their explorations on the moon, the sharp-eyed Harrison Schmidt spotted what he called orange soil. And he was all excited about, I found this orange soil. Well, here's this color picture. It doesn't look orange to me. It looks kind of like dirt. But he calls it orange soil. And as it turns out, it's very significant because most of the material that they had brought back had been breccia, which is soil material and soil rocks that are caused by impacts. This was actual volcanic in nature, and so as you see in the picture on the right, you can see how that actual soil looks like under a microscope. So Apollo 17 returned, and that's the last time man has walked on the moon. Hopefully in the future we'll have additional people walking on the moon. But next slide. But there were a number of missions that NASA performed prior to Apollo in order to gain knowledge and learn how to go to the moon. And the first one is probably the program that everybody forgets about, and that's the Ranger program. And the Ranger program, I remember growing up as a kid, watching this, and it was a very simple concept. They designed this probe to go to the moon, take pictures of the moon, and just keep taking pictures all the way until they hit the moon. And And the first 6 missions were absolute failures, and NASA really looked bad for a while. 3 of the missions, the equipment just didn't work. And then there were 3 missions where they just completely missed the moon. They didn't lead it enough, or didn't account for the motion enough, but they just completely, the Rangers just sailed right past. But eventually on 7, 8, and 9, they were able to get the results and take pictures. And in the series of pictures on the right is examples of the pictures that were returned by Ranger. And in fact, what you see there is the eventual landing site of Apollo 11. So next slide. Then NASA decided we need to practice landing on the moon. So they sent up Surveyor. Up until that time, there was actually an argument amongst astronomers that the moon surface may be so dusty that anything we landed on there would just disappear into the dust. And what Surveyor proved was, no, you could actually have a landing on the moon. Yes, there is a layer of dust, but there's harder soil underneath. And each surveyor had a digging and scoop that would dig trenches, and Surveyor was able to send back pictures and inform the scientists on what kind of makeup the moon had. So we got a great deal of experience of going to the moon prior to the actual missions of Apollo. So we come up to the next slide. So now we're sitting here.
Before we get there, we do have one question going back to Apollo 17. And the question is, did Apollo 17 have a weight limit on the samples they brought back?
I think there was a weight limit. Obviously, they did not exceed it. But I do not know what the weight limit is. I know during all my research, I never saw any weight limits. You have to do the Apollo 15, 16, and 17. The J missions did carry more fuel than the earlier missions, so that they were able to take off with a greater load. Okay, so we end up with where are we now? We obviously have several countries we've kind of got a race back to the moon going on right now. China is doing some extraordinary work. We're very much involved in going back to the moon, as are Japan, India, and Europe. We also have Elon Musk valiantly trying to get his Starship ready so that he could go to the moon and eventually go to Mars. And speaking of Mars, the challenges of going to Mars is far, far greater than our challenge going to the moon. We need advancements in engine design. They're looking at different ion type of drives to help get us there. There's a huge question on how to handle consumables, water and food and spare parts. And the space environment itself, from our experience on the ISS, is proving challenging. There's a lot of human factors and radiation that we have to consider. Mankind was not designed to live in a weightless environment. Our bodies are designed to live in gravity. And when you put us into weightless environment, bones start atrophying and muscles start atrophying and all sorts of, if you've ever noticed from these long-term space flights for astronauts coming back from the ISS, they cannot walk. They have to be carried out of the returning spaceship. So it's a challenge that we still have to overcome in order to go to Mars. You know, and in conclusion, you know, the space is and is going to demand new technologies and a new economy for us to continue our exploration of space. And the one part that where your astronomy club and my astronomy club are involved in is stimulating the minds of the younger people to get higher education, to get smart about science, and to get them into that position where they can help us explore space. So next slide. And so, you know, that's basically what my book, How to Find the Apollo Landing Sites, is all about. That's what the cover looks like. You can order it from Springer, you can order it from Amazon, but if you go to my website, you can order it from my website, and I will actually get paid for a change. Let's go to the next slide. And this is where we get into my shameless plug. I have written 5 books. We've talked about my first book, The Apollo Landing Sites. My second book was A Guide to the Hubble Space Telescope Objects. A lot of people, a lot of the general public see the Hubble pictures and see these very colorful pictures, and then they see some of the pictures that we take from our telescopes in our backyards, and they say, well, that doesn't look anything like Hubble. Well, the idea of this book was to show that they are the same objects. It's a lot of the Hubble pictures are using a Hubble palette, which also illuminates things that normally you can't see. So that's what that book was about. The Vixen Starbook user guide. I wrote 2 user guides, and this was one of them. These 3 books, I got paid a flat fee. So if you order through my website, I get some money back. If not, I don't get any money. So that's my shameless plug. And the next 2 books, I do get royalties off of. I wrote a book on the Next Star Evolution and Sky Portal User's Guide, which was a fun book to write. Astronomy for Older Eyes is besides the Apollo book, the Older Eyes book. Those 2 books are the most popular of my books. Older Eyes describes it's basically a survivor's guide. If it's for those who are older like me or getting older, and it's also for people who've just retired and they're looking for a new hobby. And it talks about the things that occur to your eyes as you get older, cataracts and glaucoma and things like that. It talks about the diet you need to maintain to stay healthy and stay mentally healthy, and goes into a lot of those issues. I also wrote a 6th book, which was entitled Cosmic Duets, which unfortunately my publisher and I did not quite agree in its content, and so it remains to right now as unpublished. But go to the next slide. I do have a website, jamesleechen.com. One of my sons developed this website for me, for which I'm eternally grateful for. It has my bio on it. It has links for ordering my books. If you order my books through my website, I get a little kickback, which is nice. The 2 books, I am not getting rich writing these books. Last year, I received from Springer a royalty check of 5 figures, $110.80. This is not a lucrative career, but it's a great pastime as a retired person. On my website, I also have Jim's Corner, which you will find 80% of Jim's Corner is basically my Cosmic Duets book. And so if you want to see what Cosmic Duets would have been about, cosmic duet, by my definition, was when you look through your eyepiece and you see two galaxies at the same time, or if you see two open clusters at the same time, like the double cluster. It's where you look at M31 and you see M32 and you see M110 at the same time. So that's what cosmic duets is all about. And eventually I may put into the contents of cosmic duets as a book, as a download on my website. Future content, I am in the process of writing a science fiction novel right now. And it's combined some of my experience with FAA and with NTSB and with NASA, and it's talking about the first crash of Elon Musk spacecraft with tourists on it. So stay tuned. It's still being written right now. It's about 2/3 done. So that's it. Thank you very much for allowing me to speak to your club.
All right, thank you very much. I know for myself, I can say that I've learned a lot tonight. I was very interested in the new materials and chemicals and rocks named after the astronauts, which is very, very, very interesting. I appreciate you joining us this evening. We look forward to the sci-fi novel, and I hope that we can do this again in the future, perhaps on another subject.
Well, a good subject. Another popular subject is my Older Eyes book, so I'm certainly ready to speak to any of my books. But like I said, last year I was out in California, and at one star party I gave my Apollo talk, and I gave my Older Eyes talk. So the two very, very popular subjects.
Okay, very good. John, I know John's listening. He's our program director. He'll be sure to line you up for that. All right. Thank you, everybody.
Okay.
Thank you for joining us this evening. We will be on the air again soon with some other topics and other features. Have a good night from NJAA.